Hi. I guess we can start now. So, as we have wished on Wednesday, I mean, we do have a holiday on Friday. I don't know whether you enjoy it or not. I'm not very happy because I have to make up the class, but for some of you, I mean, maybe very happy. But whether you have to make up is an issue. So the first thing to do is to briefly review. Oh, sorry, I forgot to share the screen. Is to review what we have done in the last class and then continue a journey. In the first class, we talk about mean, right, and median and mode. And the last class, we talk about the IQR, range, variance, standard deviation, and coefficient variation. Let us briefly review what we have done. And then today we'll talk about three new measures, hopefully. We'll talk about the skewness, kurtosis, and coefficient of correlation or covariance related concepts. So basically 4 new concepts, and that's the end of the suppose we end our theory discussion. And on Wednesday, we'll use Excel to do some calculation. Okay. So maybe very briefly to go over to remind you these 3 different types of measures and central tendencies we covered last week, and also the dispersion we will cover, and we'll talk about the shape. Okay. And just to remind you a little bit again, once more, what is the mean? Mean is adding up divided by n, right? Do note that that means it's the center middle by distance. So for this method to make sense, it must the distance make sense. Okay. Otherwise, the centrality is a kind of issue. Okay. So just to remind you this picture, right? The mean is the center where the left distance, sum of it is same as sum of this on the right. Okay, red, same as blue. Is it exactly center, right? If you learn physics, right? You just where if there's a where you the seesaw where you put the location of that thing, the clockwise moment, same as the anti-clockwise moment. But I'm not talking about the physics, but that is how it's being defined. And just to remind you, one thing is affected by the outlier a lot. Okay, so that's why you use trim mean or Winsorized mean. Okay, and last we talk about median. Okay, by median we mean is exactly the middle of the data, right? And exactly middle, if you have odd number observation, the exactly middle guy exists in the data, right? You have 3 guys, the second guy is the middle, right? You have 5 guys, the third guy is the middle, right? But if you have even number of observations, then your problem, right? Suppose you have only 2 observations, where's the middle? It's 1.5. But how can I calculate 1.5, right? It's the midway between first and second. So that's why average is half, right? How do you say if you have 4 observations, right? The middle is 2.5, but it's 2.5, halfway between 2 and 3. So that's why average, right? Actually, this is what we call linear interpolation, right? It's linearly how you collect them. And the next one is mode, right? Mode is the most observed data, which means that it doesn't require any calculation, just require counting. Anything you can count, you can do mode, right? But if you can't count anything, there's no statistics, right? The count is the most basic operation you can do for any kind of data, right? So that means that this is the least requiring measure. So that means that you can apply to any data you want without any worry about whether there's some limitation you are not aware of. Okay. And the next set of measure called dispersion, if you remind yourself, is the central tendency give a single number that represents whole data set, right? And dispersion give us how accurate it is, right? So the first measured range is the largest minus smallest, tells us how spread out the data is, right? And the second is IQR. I believe some of you still puzzle how to calculate that, right? Because there are 3 different methods and you learn 1 or 2 in your high school. And as we said, to be consistent with the Excel, we'll use the third version, which is the linear interpolation, right? Because the first 2 version basically is calculating 2 quartile by median, right? And whether you count the middle guy, the first median you calculate, whether you include in the 2 halves, we distinguish the 2 methods, right? And the way we do is from this definition is n+1 over quarters rank, right? And that's why whenever you calculate the first quartile and the first quartile, okay, what you do is you have to n+1 over 4, and you calculate where it is, right? And it depends where you are, you just add up the fraction, okay? I'm not going to go into details of this because we'll do assignment. Then you will work on those. And for this year, because always last year I received a lot of questions about what additional exercise you may do. I asked our TA to input some of the multiple choice question. You can do it on your free time. Okay. They will upload the Blackboard. You can do as many as you want, but it's not counted for the credit. Okay. You can just try on your own pace if you want. You can have more exercise. But of course, this is introductory stat class. So basically, whatever stat textbook pick up, be fine, right? And most likely you pick up the book. Usually you have odd even number questions have answers, or even number question have answers, right? So whatever book you can pick up will be fine. So the second set of the data is related to dispersion related to the mean, right? The distance to the mean, right? And the one we focus on is called variance, which is mostly used measure besides the mean, right? Basically, if you come out this class, the 2 things you would have to remember, because it appear all the time, is the mean and the variance, right? Or mean and standard deviation. This often appear, right? If you try to talk to people, talk about statistics, this is 2 things they would remember from the class, right? One is the first is the mean, second is the variance, right? And the variance defined as actually the mean, right? It's the mean, but you talk about square distance from the mean, right? It's the mean of the square distance from the mean, if you want to say that, right? It's for each data, you calculate the distance from the mean, you square it, average of that is the variance, right? This is the formula. I mean, it's easy to calculate. And do remind you that there are 2 versions of the variance. We'll talk about that on Wednesday when we do calculation in Excel. And you'll notice that variance is called variance P with the first one, variance population, and the variance .S in Excel. You notice why we have the 2, right? Suppose that the whole data you want to study, and you look at the variance of this data set, use the variance P. Okay, you tell us the variance of that thing, right? But later, some of you ask me why we have the sample version. It's later when we learn in topic 5, what type of estimation, and we want to use what we have to infer, to guess what happened in the big picture. Okay, that we use that one. The reason is being dynamic iterated again, because you're estimating variance of the whole thing, but you only pick up part of it, right? So pick up part of it, the variance tend to be smaller. So it adjusts. Often all the time when you try to measure something, put the data, you need to do adjustment. Later you will see it can be very complicated to do the adjustment, okay? To get the accurate measure. But just like you play basketball, right? If you want to shoot a 3-point, right, far away, if you're good enough, you're very good. You can just throw in, that's no problem. But in general, most people are not good enough. You have to rebound from the square, right? That's the easiest way to handle the problem, right? So that is why n-1, that makes bigger. And I hope you would try to figure out this is right. And if you take the square root of the variance, you get the standard deviation, right? So as you can see, the name suggests standard deviation. The deviation that's so standard is so common. It's common deviation. So that's why SD, right? That's the standard means. Okay. And probably we talk about this. If you read some book probably you would read my lecture notes. Did I upload my lecture notes? Or I'm not. If I didn't, I should. Oh, I forgot to upload the PDF, but it will be there later. It will be saying that there are many property related to the mean and standard deviation. Okay, there's several rules saying that it is usually within 3 SD, okay, or 2 SD, depends on the shape of the thing you do. There's a many inequality that related to the mean and standard. Probably we'll talk about this maybe later, but that SD is very useful concept. Okay. And finally, talk about the series. This is very useful when you compare across data set. Okay. When I try to say, as last time I said, you want to say the variance of the mean of the variance of the midterm versus variance of the final, right? And the problem of comparing standard deviation, say, problematic, is because midterm, usually the score is from 0 to 50, right? And the score for the final is 0 to 100, okay? And by definition, the mean is higher, I mean, in general, right? For the exam, right? So you can normalize it to divide it by the mean, and then you can compare different data set easily, right? So that is the idea that behind you would want to use the CV, right? Because there's no more unit, right? Because standard deviation had the same measurement unit of data, and mean also have the same measurement unit. So that's why the CV has no unit at all. So that means that no matter how you measure the data, either in inches, in centimeters, in meters, no matter what, the same thing. So that is to compare across data sets. Okay. So I hope during your typhoon holiday, you take your time to do this calculation to verify that you understand what's going on there. Okay. But don't worry if you forgot to do it. We'll give you an assignment that you have some time to work it on again. You work on these problems. Okay. So as hinted, we will introduce another measure that actually fit the college level. Right. So far we have do the mean, median, mode, range, IQR, variance, standard deviation, or CV are probably some of you might have learned in the high school, right? So why we learn something in this in college again is because of two new measures that you have to learn it, and you will find new applications to those. Okay? And you will see them in Excel, right? So when you are college, then if you use Excel, you have something to understand. Now it's something you understand. Okay. Actually, you will see the kurtosis and skewness is very, very similar to variance. Okay, they're similar measure of variance, but let me define it. Okay. First, look at this measure. Okay. It's a little bit crazy, but first look at the. Maybe I should get the highlighter. Okay. Look at the skew. This numerator. Okay. This numerator. Okay. Looks crazy. Okay. But if you forget about the cubic, become a square. If it's square, that's a variance. Right? Remind yourself it's square, that's variance. Right? Now I change to the third. Okay. And what does they do? Okay. Remember square. It means what? Square is always positive. Right? If the number is above the mean or below the mean, it's always positive. Square, right? Because minus, if this is xi is bigger than this, positive, no problem. Whether it's square or cubic doesn't make a difference, right? But when this observation is below the mean, it becomes negative. Negative to the cubic, still negative, right? So that means that this guy can be 0, some of it Can be negative and positive. Any sign is possible. Okay? And remind yourself that if this is 1, this is 0, right? It's the middle of that, right? And if square, it's more positive. Okay? It's only 0 is every point, every data is on the same point. Otherwise, it's positive. And it's cubic, it means that it reflects how symmetric about the mean. Okay? Let me graphically illustrate what does that mean by symmetry or left skew or right skew, then you will see what it does mean, okay? So before I go, I just jump a little bit ahead, okay? To look at the graph first. If 0, it easily means just a diagram, okay? Not need to be this shape, but usually you will see symmetric means this is the mean here, the left-hand side and right-hand side is symmetric, okay? It's more or less the bell curve that you used to learn, usually symmetric, okay? In many cases, this is fitting a lot of data, okay? And that's fine, okay? But sometimes data look like this, okay? You probably can tell me what kind of data you observe this, right? This is the data where the mean is higher than median, okay? If you remember our examples, leading example is income distribution, how much you make, right? And where often you have very rich people making a lot of money, right? And because of minimum wages, usually the people doing here is not a lot, right? This is the shape, its income is like this shape. Okay, this is when you calculate the skew is positive. Why? Because there's a bunch of people doing a lot of money, and if you raise the power 3, this extreme value will expand, right? Crazy, right? Overcoming the effect of the lower number. Right? So this is how you would get. Of course, I'll give you some number example to justify this is right. But this will be the graph in your mind when your positive skew or right skew is like this, okay? And the other example that you would, in your mind, is negative skew, okay? And this is the distribution that I will face at the end of semester, okay? I look at your GPA, look at the grade, exam, final exam, or all the grade overall add up together, you should look like this, okay? And the mode is usually a B+, something like that, right? And most of people here, but unfortunately, I cut out some here, some got A here, some got A- here, and B+ and B, and so on and so forth, right? Because you guys are in CHK, right? Which is the top school in Hong Kong, right? When B school, also top school in the faculty, right? So you guys are top of the top, at least in Hong Kong. I cannot say the world, but at least in the QS ranking, we're the top 50. So probably we're top of top, right? Of course, not Harvard and Stanford or whatever, but it's already very top. So this is normal, right? Of course, if you try to do it in general in Hong Kong or elsewhere in the world, it's going to be like this, right? But since we are in the B school and you guys are very good, so this is the case. Right? Is that okay? Now, let's go back. Hopefully, I give you some intuitive idea what it is, okay? So that is the numerator, okay? And you ask, okay, why I have to divide it by the standard deviation raised to the power 3, okay? And this is just to a normalization to make sure two things. One, this measure has no unit, right? No matter you measure in centimeter, matter in inches, matter in feet, whatever, same. The second idea is because I want to avoid when the data is a lot of dispersion, right? I divide by SD means that the dispersion is even out, right? Of course, some people do not divide it by this guy. It's divided by the cubic of the mean, right? Same, you can imagine you can divide this following the idea of CV, right? You can raise to the power 3, right? But this measure is used in Excel, so I followed Excel. As I told you, right? Skewness have many ways to measure. This is the way use Excel, we follow it, okay? Because our class is based on Excel, okay? And if you write down this formula, this like this, right? The SD 3/2. Is that clear what we're doing? Okay? Now we know this formula, okay? You may ask, okay, how do we do in the data, right? As I see, when we do standard deviation or variance, the sample version is different, right? So it turns out that this is rather complicated, right? Turn out to be, to estimate this, okay? Turn out to be, you take a adjustment factor, is not n over n minus 1, it's a very complicated thing, okay? Turn out to be, this is the formula you will use. And of course, as it's a black, I don't expect you to remember, okay? The reason I put this is because Excel, I'll put this guy, okay? Excel will calculate this guy for you, okay? If you do the skill.s, this is the thing, okay? And I will illustrate by example how to calculate this, okay? But this is also the number come from Excel, okay? Which we'll talk about this in Wednesday, how to do Excel calculator, okay? But let me go to the example slowly and show you how to do the calculation. Okay, it's not complicated. Okay, now we start with the first column, which is the data, and second column is the mean. The third column is subtract the data from the mean. Is maybe I should use the Anthony. Okay, this is subtracting. The third column is subtracting 1 minus 3 is -2. Okay. And then you do for each column, as expect, some of them is 0. That's the definition, is the center. And the fourth column, right, is square. Go to this one, right? -2 is the square, right? And sum of that is 10, right? Nothing new there. And look at the last column, which is raised to the power of 3. Okay. So -2 times -2 times -2 is -8, right? Or you can multiply the third and the fourth column is the last column, right? You multiply the blue and the red, give you the purple. Okay? And not surprisingly, some of the last column is 0 because 1, 2, 3, 4, 5 is symmetric about 3, right? So no matter how you calculate the population skewness, and the sample version is always 0, right? Because the numerator is 0. Right? So population skewness is this guy divided by 5, which is 0/5, right? And this guy is the standard deviation. Right? Standard deviation is 10/5, right? And take a square root, right? And you want to raise to the power of 3. This is 0. Okay? And if you want the sample version, you first to calculate the sample variance is 2.5, and you take square root of that, right? Raised to the power of 3. It's n minus 1, n minus 2, that formula. Okay? So get with 0. Okay? So to illustrate how you do this 2 calculation. Okay? I hope that should be okay. Is that okay? Just plug in the number. So as I said, this open book, so I don't know, just need to know how to plug in the number if you ever asked to calculate that, right? So there's nothing, you don't need to remember what's going on, but you need to know this is a formula for sample variance, the sample skewness, the population skewness, and then you just calculate. That is nothing very deep here. Is that okay? This is n minus 1, n minus 2. Just to remind you how I apply the formula here, in case you forget, right? So the formula is here, right? So you have the n here, n minus 1, n minus 2, n is 5, right? Sum of this is exactly the column sum of the last column, right? This is S is that guy, right? I hope that shouldn't be an issue. Okay. If you're still confused, ask me in the break or ask the TA, or if you still have problem. Okay. Is that okay for the skewness? Okay. Now, probably you would ask, as already I mentioned, why we care about skewness, right? First thing is, in this class, we'll focus on the bell curves. Probably later you mention what's a bell, the normal distribution. And for the bell, it's always usually symmetric, okay? And a lot of application, when look at data, will satisfy bell. That's no problem. But many cases, bell fails. Okay? The bell fails. And why the bell fails? Because the data is not symmetric, it's skewed. Okay. And the question probably you ask is, what happened to the tools we learned from this class? In general, it's not a big issue, but sometimes it's an issue. Then you require more advanced tool that beyond this class, right? Very normal, right? Our class is introductory. You can't cover everything, but you will ring the bell that the tool you learn requires some upgrade. Okay. And example here is I mentioned is a lot of cases not symmetric. Okay. And when you check those, then what would happen? For example, financial crisis, right? It's a case where there's the price or the return significantly negative, right? It's very rare, but it happened, right? Look like this. You look like this, right? If you, something like this happen, right? In general, right? Stock return, stock price would behave normally in this way, right? But when financial crisis, that day will be, one day can drop by 20%, 10%, 5%. That's abnormal, right? Usually it's between 1% and 2% plus minus, right? But financial crisis, the day become like this, okay? And how can you know the your data is okay or not? Check the skewness, right? If it is, the data is skewed, then using the standard technique would lead to some problem. Okay? Or why we care about skewness for those who say finance. Okay, if you learn finance investment literature, the predominant thing is about risk and return, right? You learn investment class is like, if you want higher return, you need to take higher risk. That's the end. That's the usual wisdom, right? Since the starting of investment, right? Maybe 50 years ago, right? And mostly the people call CAPM, the model, those kind of ideas. And recent 10 to 20 years, right? People start to realize that people not just think about risk and return. The one thing is also given is called skewness, right? Or some people call the ghost stock or the crazy stock, right? The stock that actually have high potential jumping up. Like people who find who's the next Google. People want who is the Nevada, right? People for to find who is the next OpenAI, those kind of stuff, right? People expect some stock that have to be grow a lot, right? It's skewness because the stock have a very very low value, right? If you lose all the money, that's fine. Right? Maybe $1, you lose everything is a zero. But the potential can go up to 100 or 1,000, like Bitcoin. In the beginning, right, can be worth a little bit, right? Or the cryptocurrency suddenly become a very valuable stuff. So people pay premium for that. Okay. So if you talk about risk and return, they're not sufficient. You have to talk about skewness. And recent 5 to 10 years in the finance research, people start to recognize this. And skewness will be part of the pricing factor. Okay. So if you learn investment class at the graduate level, not the undergrad, the graduate level, they'll talk about those. You're a master. But undergrad, if you're undergrad, probably you go to a 3,000 class in finance investment, they still talk about risk and return, okay, standard. But now people talk about skewness. Skewness also price as well, okay? And that is what I meant in the third bullet point, okay? Okay, and the second bullet point is about why people buy lottery, right? And explain economics or business decision, why people Now these days, you go to somewhere on the street, right? Many stores are closed, okay? But every 10 store closed, there are 17 store open. And out of 7 most store, you will see a lot of store are trying to is a door grabbing shop, right? Go to the store, you pay some money, and then get the machine, right? You control the machine, is grab a very large door, right? And usually, right, it's not going to be successful anyway, right? And you may successfully 1 or 2 cases, right? And you may ask why people would do it, right? Because the cost of getting the door, right, paying the machine is usually more expensive than you just buy right away. Why people do it? Or why people in Hong Kong sometimes would go across the sea to the Macau to gamble, right? And you know, probably a few class later, we learn mean, right? In general, expect to lose, right? And why people would still bet? It's because of skewness, right? You lose all your money anyway. But there's a high chance you get a lot of money, right? That's why people would buy lottery. Why people do Mark 6? This is the reason, because of people care about not just mean and variance, care about skewness. Okay, there's a high chance of getting a lot of money. Then you may aim for that as well. Okay. So now, if you have been comfortable now by the mean of skewness, then you would not be very surprised to see something can be applied similarly, okay? It's called kurtosis. And kurtosis is changed the skewness number 3 to 4. Okay, if you remember the formula, skewness and kurtosis is basically 3 and 4, right? Change from 3 to 4, right? Skewness is 3. And kurtosis is 4. Okay, and the question is why? What I'm doing here? Okay, why we do that? All right, and do remind yourself that when we raise to the power of 4, means that everything will be positive again. There's nothing negative, right? Square is already positive, and square again is also positive as well, all right? So, and then you divide it by the standard deviation, right? And some of you may, if you overlook, you will say, okay, so then it can't all be 1, no, right? Because you would take the cubic first, right? You square and then sum of them square. But this is just, you raise to the 4th, so you will never be canceled out, okay? And you will ask, what are we doing here? Why do that, okay? And if you look, this is, I square and then sum and then square again, right? And here is, I take the 4th time, right? And what does that do? It means that if your value is far, far, far away from the mean, you raise to the power 4, it will become a huge number, right? So if you have outlier, okay, if very far away from the mean, okay, either side, doesn't matter with negative, positive, raise to the power 4, this number will be huge, okay? That means that we want to detect outlier, okay? Or we want to look at the tail. That's why people call this measure of the tail fat tail or thin tail. There's a lot of outlier or less outlier, okay? Again, probably you ask why we care about outlier at all, because it related to validity of the tools that we're learning for the rest of the class, okay? For the rest of the class, we assume the data is more or less symmetric. There are not many fat tail, no extreme value, so everything applies, okay? And if you have a data, you figure out that it's highly asymmetric, the data, a lot of fat tail, so you can't use the tools we learned from this class. So basically what we learn is like a bell and whistle that you may ring it, okay? You need to read more if your data exhibit this kind of problems, okay? So, and probably you would ask, okay, skewness, I compare to 0, right? And that's left and right, okay? Positive or negative, right? And what is the benchmark kurtosis? How big is big, how small is small, okay? Turn out to be, it's very simple. We compare this number to 3, 1, 2, 3, 3, okay? And Why 3? Because 3 is the one if you have the bell curve, the bell standard thing. You learn bell, I think in the 4th topic, there's a bell curve. And bell is the most common thing in the world. And as I mentioned in the first class, that is what we call central limit theorem. Turn to be if things are nice behave and everything will have a bell. Okay. And bell is called normal distribution, or the bell distribution, Gaussian one. It's the most common one. And we always want to compare what we observe to the bell. If more than bell, that means you calculate the kurtosis minus 3, okay? It's called the fat tail. If less than 3, it's called the thin tail. And there's a grid thing, it's called elliptokurtic, platokurtic, and mesokurtic, which I don't remember. We need to remember, but the people who like to write thing in a cryptic form will be something like this, okay? I think I use the layman term fat tail or thin tail, right? That would be the thing that I want to look at. Maybe give you an idea what is a thin tail and fat tail. Okay. The blue one is usually what we call the bell curve, look like this. Okay. If you have the red thing, which is the tail is bigger, it's fat tail. Is the thing, the golden one is a thin tail. Okay. And as I try to remind you again, why we care about fat tail or thin tail. Because in general, we use, when we do calculations, we assume bell curve, because bell curve apply to a lot of situations that's coming from central limit theorem, okay, which we'll learn later. But a lot of time, like the income distribution or those things doesn't fit well, okay? So that's why you have to worry about those. Of course, when we talk about income, suppose you kick out the billionaires, millionaire, look at normal people, it's still bell curve, okay? But if you want to incorporate everything there, you have some issue there. Okay. Now, here comes a monster slice. Okay. And again, you wonder why I have this monster slide. It's because Excel gives you this. Excel formula. Excel, unfortunately, don't give you this guy. Instead, they give you this guy. Okay. And you will never understand what Excel gives you if you don't know this formula. Right? Because Excel gives directly this one. As I said, why we want to do this, because if your data, if you want to estimate what happened, this is what you do. Okay. And this turned out to be a very complicated formula. Okay. I'm not going to explain, but I think it's very clear what's going on there, right? This N is sample size, and Xi the data minus the mean, right? Over the sample SD, right? Remember, sample SD is the you take each observation over the mean, but over n minus 1 instead of n, right? And then the same thing. Okay. Don't ask me why I do that. If you want to learn how to do it, it's a graduate level, or at least you go to stat department, they will teach you. Okay. In the business school, we just take it as given. Okay. If you want, there's a lot of proof. Look at the original proof is there. Nothing new there, but this is how you estimate, and Excel gives you already. So don't worry about it. Okay. As I said, the black thing is not the thing I would ask you, so don't worry about it. Okay. But I need to put it here in case you want to check whether Excel try to make sense of number Excel give you. Okay. Just to remind you, you are not required to do this at maybe in the assignment, but not in the exam. Okay. The black thing might be an assignment, right? Because make sure that you work a little bit, but exam is not. Okay. I will not asking the black in the exam. Okay. Okay. Before the break, then I want to quickly go over 2 examples to show you that they are the thin tail, the fat tail. Okay. And you will see this data 1, 2, 3, 4, 5 is like way flat, right? And you will see this turn out that this is exact kurtosis negative. Not surprising, right? Because it's flat. Right? So let's do the calculation. Okay. One by one, I go slowly because I want to make sure that you understand the logic. Okay. The data is up to 5. The first column is exactly this guy. Nothing new. The second column is the mean, right? Mean is what? Sum of all observation divided by 5. Right? This gives you this one. The next thing is you do subtraction, do this guy, right? 1 minus 3 is -2, so and so forth for each observation, right? Adding up is 0, nothing new. That's definition of mean. And the fourth column is you take square, right? -2 times by itself is 4, so and so forth. Sum up give you 10. And the last column, let me use, I don't know what color, maybe deep purple. You square again, 16. 1 is 1, 0 is 0, 1 is 1, 16, 34, right? And the population kurtosis is very simple. 34 is here, 34 is here, right? And there's 5 data point here, so there's 5, right? 1, 2, 3, 4, 5, n, right? This n, right? And look at the denominator, right? Denominator is this guy, I mean it's green, right? 10 is here, this 10 is here, right? Again, this is n, right? This gives you the variance, right? Variance square, right? Variance square, right? So square, this is how you calculate the population kurtosis, which is easy, right? And the excess kurtosis minus 3 is -1.3, right? So that means that this is much thinner, the thin tail, not fat, thin. And this sample excess kurtosis is a crazy thing, right? But if you remember, this is n minus 1, right? This is n minus 2. Oh, where am I? Right. This is n minus 3. So minus 2 is n minus 3, right? So that comes the thing, right? It's n plus 1 and n minus 2, n minus 2, n minus 1, minus 2, minus 3, right? And this is 34 is over there. And this is sample SD, is S, right? So this formula. Okay, I hope if you don't know, then you can just ask me or ask the TA during the break. Okay, this is the thing that I hope you know how to plug in. It's nothing new there. Okay? And during the break, you should try to see if you can make sense of all this number. Okay, I just try to see this number is 1, 2, 3, 4, 15. Right? As you can imagine, there's a large number outlier 15. Okay, and you expect the kurtosis is large. Okay, and this justifies our case. The sample one is 4. Okay, and you can see the population one is still positive. Okay, but this is much smaller. This is better estimate. If I try to use this to guess what's going on. Okay, if this is the data you have, and you only care about this is what it is, you use this one. Okay, whether population or sample depend on the purpose. Sorry, as I said, same as the sample mean, sample variance, and population variance. Okay, okay. So sorry to take one more minute because that will be more complete is to explain why we care about that. Okay. As I said, in finance, right? If you learn stochastic calculus or you learn partial differential equation or this calculation, they care about mean and variance. They are assumed normal, like Bexel's equation or all those finance equations. The problem of that, they cause financial bubble or thing is because they don't care about the kurtosis. They forget the outlier. Okay. Of course, skewness is thing, but kurtosis is the thing they missed. Okay. You forget the extreme event. Or the main thing, if those who study insurance, in fact, for them, the kurtosis is the key, right? Because in general, for insurance, there's nothing happen. No need to pay anything, right? But if you look at the past 9 years, nothing. But the 10th year, you have something happen, okay? If you don't model your data based on right kurtosis, you make losses, right? So I have to take into account of those. okay? Or the bank try to lend money to people, right? And to calculate the risk management, you have to think about those, okay? And kurtosis is when we talk about economics or talk about income, kurtosis is the way that you measure inequality, right? Or you can imagine, as I said, the business application, you talk about how much people want to spend your product, right? Kurtosis is important, right? If the kurtosis is high, you probably don't want to introduce one version of the product, right? You may want to have some product cater for the extreme rich or people who don't have enough money, right? You segregate the different version, it'll be helpful. If the data is not so much fat tail or thin tail, then you'll be okay. Okay. But do note that the kurtosis and variance are, they look at something similar, but they are different measure, right? Because of course, for data of high skewness, sorry, high kurtosis, you also have high variance as well, right? Should be, but depend, but they're different thing because you remember you calculate the kurtosis, you divide it by SD. Okay, so that's why it's they're relatively distinct concept, right? Things that have very small SD but very can have very high kurtosis, right? So have to be a little bit careful about that. Okay. So I guess the time to break. After the break, we'll talk about how to relate two set of observation. So far, we learned about everything we learned, given single one-dimensional measurement, how to describe it. After the break, we talk about how to relate two things. Okay, but in the meantime, have a break of 15 minutes, and I will do the U reply where you can answer. You can tell me how well you're going. Okay, let's do a break. That's a break of. Okay, tell me how well you're doing. In the meantime, I will go around. Let's resume in 15 minutes afterward. Let's resume in 14:59. So I guess almost time we can look at your feedback and see if I can answer some question that you might have. I will attend your lesson. Thank you very much. Need to clear concept. Okay. So maybe I just repeat a little bit. Some of you asked me, can I speak human language when I talk about skewness and kurtosis? Okay. The human language for skewness is just asking whether the distribution is like this, or this, right? That's it, right? Positive in your side will be like this, right? Negative like this. So that's human language, I hope, right? And for kurtosis is very simple. Again, it's asking whether, right, this, right? If like this is thin tail, it's normal, this is fat. That's how it is. Nothing very deep there. Is that clear? I hope it's clear what it goes on. I hate suddenly. I don't know about math because so far you haven't seen any math, just come calculation and just apply those. Okay, there's no math so far, just arithmetic. Although tedious, but remember, we do Excel, right? So the math, the formula, just telling you how you calculate those. Okay, just understand what you're calculating. Nothing deep here. Okay. Typically, how many percent is A? From historical understanding, A and A minus range will be 30%, something like that. And the division depends on how people are doing, right? But this is all historically. I mean, there are a lot of deviation. This is the mean, right? I would say, right? There's still a lot of variation goes on here, right? I hope I answered the question. Hello world. Oh, we do not do hello world in this class, unfortunately, just Excel. So we don't do hello world. Yes, tail is exactly what it means. Tail is exactly the rare event. So difficult. Is my midterm and final to fail? No, because there's no midterm, so you can't fail. You can't fail midterm. Final, well, so far the case is no one actually failed the final if they have attended a final for this class in the past. So if you don't attend, then I mean, for sure you get failed. But so far for those who attend, it's not. I mean, you can try to see if you can fail, but it's not that easy, I would say. I mean, if you do the assignment, if you bring your lecture material to the exam hall, then if you still can fail, then I admire you. And you don't understand why this kurtosis. As I said, skewness and kurtosis is to check your data, whether it falls within normal, right? If excess kurtosis is way bigger than 0 or way less than 0, same as the skewness, then the tools you learn from this class doesn't work. You need to study more to apply, okay? So it's a bell and whistle to check, okay? And I tell you that there's a lot of cases whether the skewness and kurtosis require additional modeling, okay? So that's the reason why we learn it. And I told you the skewness is valued in finance asset pricing. Stock have positive skewness would carry some weight. then explain a lot of things, the skewness. Okay, I hope that explain why we need that. And kurtosis is right. There's a fat tail that explain a lot of case when you try to model disaster or model financial crisis, you require to use kurtosis. Okay, or that's what we learn, right? Risk management, value at risk. You care about the tail. Same idea here. Bell is actually what we learn normal distribution. It's line curve. It's like we learn, right? There's a bell thing. Always in genetic sense, it's always a bell thing. Okay, bell curve. Maybe it's what we mean normal distribution. We will learn that in the topic 3, but there's a bell. Okay, there's a bell curve we will learn. It's invented by a famous mathematician, Gauss. But as I said, most of the thing will follow this bell style stuff. Okay, but in many cases, when we care about the social science, the human world, it's not bell. Bell often comes in nature. Okay, but when you do to the business, then bell usually fails. Okay, but when you learn mathematics and statistics, usually come from laboratory in the beginning, right? So that's why they look at the bell, right? But now we are approaching our real world social science, then bell thing doesn't work very well. But you understand more about bell in the later. Hopefully, can I use Chinese to speak again? Unfortunately, no, because we have to talk in English this class. You sign up for this section. So you have to, if you do Chinese, then you have to go to our section. And if you really want Chinese, it cannot by me, can be by the tutor. Go to the TA, and then he or she can talk to you in Chinese again. Okay, or you can ask me during the break. Okay, and we cannot talk Chinese in the class. I'm sorry about that. But do remind yourself that what I want you to know is the purple box in the lecture slides and the green, how to execute. If you learn those, that's fine. Okay. Other than that, mainly the green one. If you know the green, then you're done. Okay. There's something that I cover beyond what is supposed to be. That's fine. Okay. You don't have to learn 100% to get an A, right? As long as you do the green thing, that should be all right. Yeah, actually, if you learn all the green, you can get an A. Not a big. I mean, of course, given that you get a project doing all right, but otherwise, that will be the case. Okay. Now, surprisingly, today people still think it's Friday. Probably they still have the symptom of the typhoon is left over in their mind. But I'm pretty sure that there will be no typhoon on Friday. If it does, then it will be a very rare event. I mean, that we have some skewness goes on or kurtosis goes on here. Okay, that's good. But still, 6 people think it's sunny today. Maybe all right, but it's fun. One key point is open book is very important. Yes, you don't have to write a formula because now information is so easy. I guess the problem is how you apply, not to remember the formula. So I don't want to waste your time to remember the formulas. Yeah, kurtosis skewness. Yeah, skew the data, the shape, and the thickness of the tail. Yes. So basically, if you this is the thing you check the first. Remember, you tell your boss you have data. This is the mean. That's the thing that you want the boss to know. Second, tell them the variance or standard deviation. Tell him how accurate the data is. The third, you want to tell him the skewness. He had the idea whether the data is skewed left or right. And next, you tell the kurtosis is whether fat tail or not. If the skewness and kurtosis doesn't violate too much, then you can proceed to the standard way to do. Otherwise, you have to pick up the thing you will learn in the high advanced class to do more complicated things. I hope that explains why we're doing this. Right? Because if you don't learn skewness kurtosis, you will proceed as what we learn, then you may have trouble. Okay? For now, you learn If there's something you learn in the high school, okay, there may be some issue there. Okay, we have to be very careful. Okay. Yeah, 偏到. So someone won in Chinese here is what it means. Okay. So far it's okay, although I have 3 people hate me, but I read the course overview. There's a lot of stuff to learn. I can't say across all the section I cover the least amount, but there are other sections that cover more than I do. So I think I'm on the median side, maybe slightly below the median. Okay, but I cover the most important part that I think I still use it and I think still useful. Okay, and I said, although I cover a lot of material, right? But the green part is the part that you have to master in order to be okay or to get the A in the exam. Okay, of course there are a lot of things, right? But if you only care about your exam score, right? That's the thing, right? Of course, you still need a lot to do a good project, right? But I hate raining. Some slight rain is good, but you're right, rain is not good. Usually people can't shoot basketball. Yeah, I don't. But I learned how to shoot, right? But I don't know, I don't shoot very well. Oh, that's bad. So someone said they play mahjong and they're trying to do a very big one, and just suddenly got by the other guy, so he cannot finish his big stuff. So it's a joke. Okay. Oh, means this is it's a joke, same as congee in Cantonese. So he hates congee. Oh, I'm sorry about that. How old you are? Well, I don't think we're elderly in our room, but maybe that someone have some issue with the bones because of the humid weather. I still miss her so much. Oh, sorry for you. I can't say anything. Suppose it's her is a lady, not mathematics. Okay. I hope that so last part of our lecture one, the lecture series, will be covering last is how we can quantify 2 variables. So far we're looking at one measurement, right? That's X. Now we have 2 measurements, Y. Okay. And usually we want to study how they're related. Otherwise, why we want to put them together, right? If there's only one thing, why we want to put together, right? So for example, we want to look at whether you study 1 more year, how much income you make more, right? This is a problem that you want to understand when you maybe want to do a double degree, or you want to do double major, you need 1 more year, right? Or you want to look at whether you do exchange, right? You're going to help you or not, right? Or extra more credit, right? Overload yourself, it's going to help, right? You want to see cause and effect, okay? And as I said, cause and effect using data is a very complicated business. To actually tell cause and effect is what a doctorate degree would do, okay? And we are a little bit more humble at the undergraduate level. We can only show correlation, how they're related, okay? We can't tell at the moment whether X will cause Y. We just say X and Y change together. There may be something behind them, okay, to drive these X and Y changes, okay? For example, X is education, Y is income. But there may be some hidden things that may be IQ, okay? IQ can lead to high education, high income. Or your parents' IQ or your parents' income, right? If your parents are rich, likely you have more opportunity to get education, right? Or you have more income because your parent may give you a house, right? Give you a lot of money. right? So there's things that we can't say without further details, okay? If I give you just two measurements, X and Y, I can't conclude unless I have more information, okay? And how to use other information to infer the cause and effect is beyond undergraduate study, usually require graduate study, okay? So we can only tell us how they're related by using two measures, they call covariance and correlation coefficient. Of course, they are the first step to discover cause and effect, okay? And the undergraduate level, usually people will be happy with cause and effect using correlation. And very often, when you do business experiment, this will be okay. Imagine the case, you look at a marketing campaign, you want to, say, promote a new product, okay? And by introduction of the new marketing campaign, look at how much you spend and how much sales increase. You control the sales, you control the marketing campaign, then you control them, then you can know cause and effect. That's no problem, okay? So usually it's not a big deal when you apply the business world cause and effect. So covariance and correlation coefficient will be sufficient, okay? Of course, if you want a little bit more, you need to study the graduate level. You need a master degree or even a PhD degree to establish this, okay? But this is the first step if you want to study cause and effect. And even more, we will look at very simple relationship, linear. Non-linear we cannot do, okay? Non-linear require more study, okay? We study how they're linearly related. So, although we say a lot, the formula is very simple. It just, I can see the word covariance. It's just coming from the idea of variance, okay? If you remember the formula slightly is the variance just x squared, right? If you forget about this, right? This is the variance, right? If you don't have that, right? If y and x are the same, just the variance, right? If every y is same as every x, this is just variance, right? But now they're not the same, right? So what are we measuring? Okay, what are we doing? So we want the variance to say whether if x is above the mean, is it y above the mean? If y below the mean, is it x below the mean? Are they above the mean and below mean at the same time? If they're so, positively related. Okay, let's see the graph because this is not that easy to see, but let's see the graph. Okay, look at this. This horizontal is x, vertical is y. The dashed line tells you the mean of x. The horizontal dashed line is mean of y, right? The red one is the area that if x above the mean, y above the mean. The blue one are the one that is x below the mean, y below the mean. If all the data set R belong to this area, right? Because covariance calculated by this quantity multiplied by this quantity, right? So negative times negative is positive, okay? So all the entry from the blue one and the red one add together, all positive, right? And if you look at the other side, will be negative. Why? In this red one, y is above the mean, but x is below the mean, right? Multiply positive negative, become negative. Okay. Look at this quantity as well, the blue one. Okay. This case, x is above the mean on the right hand side, but y is below the mean. Multiply, become negative. Okay. So you add all the observation up, right? So if positive, it means that most data are actually on these two areas, right? So that's why when x is above the mean, y is above the mean. or X below the mean, Y below the mean, right? So they move in the same direction relative to the mean, right? If they move to the opposite direction, just they are in this one, okay? So you can, later you can tell, right? Probably can tell me, right? If X is income, Y education, usually studying more will lead to a better income in general, right? Of course, outlier, but in general, this is the case, right? And what is negative covariance? I always tell my kid, Y is your GPA, what academic achievement, X is your time you spend on your tablet, right? The more time you spend on tablet, your exam marks will be lower, right? That's how I try to tell him this historical evidence that, right, is negative covariance. Okay. So same as variance, okay? There are two things, population one and sample one. Sample is n-1. The idea is the same, just to estimation. You get a sample, it's smaller. You have to inflate to make it a good measure. Is that clear what we're doing? Okay. Then we remind you covariance what? Look at whether two variables, they move together above the mean or below the mean. More often they move in opposite direction, right? Means that if they're in good terms, they move in the same direction, right? If they're not, they move different direction. Is that clear? If that is okay, then we look at the other measure that would not be very surprising to you. Just normalization, okay? You just divide the covariance divided by the standard deviation. Okay? And again, you ask why we do that. Okay? Two reasons. Because we want a measure that without unit. Okay? And another reason, that's most important reason, is this is always between -1 to 1. Okay? The maximum is 1, the minimum is -1. You cannot have 2, you cannot have 3, you cannot have -4. No, it's always between -1 to 1. Okay? The proof, if you learn M2 math, is by Cauchy swap inequality. I'm not going to prove anything, but the proof is that. If you check the textbook, they will have that. And the good thing is, when it's 1, it's all fall in a line. Let's look at the table. Okay? If 1 look like this, okay? If it's positive, it means lie loosely on the line. Okay? If 0, it means there's no relation. You can think you can draw a line like this, like this, like this. Any line is possible, but none of the line will be good fit, then 0. Negative look like this. -1 look like this. Right? So that is very simple, right? The closer to the negative is negative, right? Closer to positive is positive related, right? So this gives us a good measure of how two variables related, right? And because it normalized, you can compare two data set, right? You can say maybe, right? Maybe for men, correlation coefficient for income and education is higher than women, so on and so forth, right? There are many things you can say, but that would be how we measure. Okay? So just to remind you, just divided by the standard deviation. Okay? And some of you ask me why I have the population version. I don't have sample one. Okay? The reason is, for this case, sample and the population are the same. Okay? The proof is very simple. Because you divide everything by n-1, they cancel out. So the sample one called R, same as the row. Okay, the same thing. This happen to be coincide for this one. Okay, so the sample and the population are the same. This is a very special case. Same as sample mean. Mean actually doesn't distinguish the sample and the population one. Right? Some of you ask me why the mu and X bar. Yeah, we always X bar. Mu is the population one, but we don't want to introduce new notation. We will talk about mu at the topic 4. Okay, so I guess the good, as I said, we always focus on green. Okay, this is a slide that concludes our theory class. On Wednesday, we'll talk about Excel. So let's go over this slowly. Make sure that you understand every single aspect, because basically we calculate everything in this slide, okay? Except there's some missing, but most of things are here. So the data set we have is, we have X is 1, 2, 3, 4, 5, Y is 4, 7, 6, 4, 9. So this is our data set, okay? Now, the first thing to do is to calculate the mean of X and mean of Y. Mean of X is 1 plus 2 plus 3 plus 4 plus 5 divided by 5 is 3. Y by 6 is just add up everything divided by 5, which is 6. Y, this is 10, right? This is 13, add up 23, 20 plus 7 is 30. 30 divided by 5 is 6. Okay? If no, you pick up your phone and do the calculation. Okay? We allow calculator, normal calculator in exam. Okay? You can bring your calculator. Okay? And you have to bring your calculator because phone can talk to each other. So remember your calculator in the final exam. Bring up your high school calculator. Don't throw it. Go back to your home, the room, the drawer, take out the calculator. Okay? Now, this is, we know the X, right? Minus X bar here, right? This is the column. Okay? This column, right? You subtract this by that, right? You do it for every entry. How you get this one is 4 minus 6, right? And do for every entry there. Is that clear? Okay? And the next one is the product, means you multiply this, give you here, right? The green one times the red one will give you the orange one. Okay? Can you see for each row how you calculate it? Take a moment and make sure that I'm doing all right. Now, once you do that, you have to calculate the squares, okay? Which is supposed not to be difficult. This column, you square itself, give you this guy, right? -2 times itself is 4, -1 gives you 1. I hope that's clear. Okay. Lastly, is the blue column. It just square from the red column here. Is that clear? Is that okay? Now, the first bullet point is asking you to add up everything, which is 7. Why? 4, -1 is 3, -2 is 1, 1 plus 6 is 7. That's how you get that, right? Add up everything here, give you this guy. Remember, this is called a summation, so I just add up everything. Okay? Add up everything is 10, because 4, 1 is 5, 6, 4 is 10. Okay? Is that okay here? The last column, 4 plus 1 is 5, 5 plus 4 is 13. Sorry, 4 plus 1 is 5, 5 plus 4 is 9, 9 plus 9 is 18. Okay? So that's how you get 18 number. Okay? And the next is how you get 2 here. You have 5 observation. Right? So 10 over 5 is 2. Okay? And how you get this light blue one? Because it's sample version, you divide it by 4, right? N minus 1. Is that clear? Now, the same thing is how you get 3.6. 3.6 is 18 divided by 5. 18 divided by 5 is 3.6. If you're not sure, use your calculator. And 18 divided by 4 is 4.5. Okay? I hope it's okay in your head. You can calculate that. If not, doesn't matter. We are not doing a mental math class. Use a calculator to do that. Okay, make sure that you understand how all the entry. If not, then you have trouble. Okay, you can do it again. Make sure that you understand. Okay, a way to practice or to prepare for the exam is to block everything I calculate. You just do it again. If you're able to do it, you should be happy with the exam, right? Because this green thing is as an exam, right? Basically, you expect I have this problem, ask you to do all the calculation, right? You should be able to do reproduce them. And covariance is what? Covariance is this 7 divided by 5, right? So it's 1.4. Is that clear? If you divide it by n minus 1, it's 1.75. Okay? So they are positive related, right? So you can see when x goes up, y tend to go up, right? But look at this number, right? It's easy, right? Because here is the right thing, right? X go up, x is below the mean, y is below. This doesn't fit very well, but this fit very well, okay? This two doesn't fit very well, right? But otherwise, but still add up is positive. Is that clear? That means the covariance, right? Covariance where they move the same above the mean or below the mean at the same time. And correlation coefficient, you can use the 7 divided by square root of 10 times 18. This one formula. The other formula is use the covariance over the SD, right? Or I can use sample version. The number is 0.5, okay? Is usually 0.5 to 0.7 is called mild, okay? Beyond 0.7, we will say something good, okay? 0.3 to 0.5 to 0.7, we say something. Below 0.3, sorry, below 0.5, usually we don't say, it's a little bit too weak to say anything, okay? Usually 0.5 is the threshold that we will say they are possibly that worth some further investigation, okay? So that is it's mildly strong, so we can do something. Okay. And why we care about things move together? That's finance. What finance is about, right? Diversification, investment portfolio. Why you put A to B together, right? Why you want to put different assets together? Because you want to reduce the risk, increase your return, right? And very often we don't want to put all the eggs in the same basket, right? We want some safe assets, right? We want to reduce the risk, and usually risk, as I said, is called the covariance, right? If you combine assets have negative correlation, you reduce the risk, okay? So very often you will see many people in finance is basically calculating covariance different assets, right? And try to figure out which combination reduce the risk most, right? And that's why people care about cryptocurrency, because they're uncorrelated with the stock market. Why people buy gold? Why people buy antique, right? They are the reason why they do it. Why people collect stamps, right? Usually it is uncorrelated with the stock. Okay. And marketing also the same idea. You have multiple product, right? And you want to see if different product, the sales are correlated or not. You want to cut the product line, introduce something different, right? That's what the marketing is about, right? If you increase price of one product, is it improve the sales of this product? But does it help the other product? Maybe complement, maybe substitute. You learn economics, you learn them, right? So correlation tell us those. Okay, you want to know, right? Because which product is complement, which product substitute, you don't know in advance, right? You learn economics in the business economic class, but they don't tell you how to estimate. These are the data tell you whether they are related, and you can decide how to marketing those. Okay. As I said, summary, because people like finance, right? You want to find a stock, how to find a good stock. You want to have a stock that have high return. Look at the high median or high mean, right? You want to have low risk, means that you want to have a low variance or low SD, right? You want to have a profit skewness because you want to have positive surprise, right? You may have a high potential growth. You want to have low kurtosis because the kurtosis means extreme risk, right? So that is to summarize what we might care about all this thing, right? Even though you just look into the data we learn, you want to look for good investment by itself. This is the thing, right? Of course, correlation and covariance look at how you build portfolio. This is how you find a good stock, and how you combine different good stock is the covariance and correlation works. Of course, what I said doesn't constitute investment advice. If you want to invest, then you should study investment class, right? But this is basics, the behind the how to drive the things, right? And a final remark, I don't want to spend time on that, is how to form a good portfolio, right? You want to lower total risk, right? You want to find things that is zero or negative correlation, right? Of course, everyone knows these things are valuable. So that's why cryptocurrency weighs a lot, right? Gold, those things are more expensive than it should be, right? And I don't want to spend more time because it's almost time. So in case you still want me to repeat, either you can look at the record lecture, which I post online later, or you can look at this I record during the pandemic. This will divide video one by one. You can look at those. Okay? So I think time's up. Enjoy. I will see you on Wednesday on Excel. If you want, you can bring your laptop or your cell phone can use Excel as well. Okay, I'll see you on Wednesday.